Good evening, everybody. Thank you so much for coming. My name is Tom Morgan, and I'm with the College of St. Scholastica. This is the third of a series of 4 programs, as I think many of you know, on the overarching theme of food. As I was researching this topic more than a year ago, I've discovered that I think we could have had about 8 or 10 different lectures on this subject. It's such a broad subject, but I think we have, I know we have 4 very good ones and 4 very provocative speakers. The next one is in March, and it will be by Daniel Imhoff, who's written a lot about various aspects of food, and he will be talking about the Farm Bill. But that's March 4th. Let's talk about tonight. And let me just promote one other thing, and then we'll get into this. This is something that we started this year, and it's, I think, been fairly successful. I feel good about it. Is that after these talks, we've had what we call talkback sessions, moderated by people in the community, to sort of critique or mull over or analyze what we hear from this podium. The next talkback session on food will be moderated by John Fisher Merritt, and I know he's somewhere here in the audience. He's a local farmer with Lake Superior Sustainable Farming Association, and that talkback session will be Monday of next week, 7 p.m., Peace Church. And I think many of you know where Peace Church is. Information about the talkback sessions is available outside, and I think you all have that. So I invite you to come to that as well. Tonight's talk, I should thank our sponsors, is, as always, brought to you by the Alworth Center for the Study of Peace and Justice here at St. Scholastica, and funded in part by the Lee and Rose Warner Foundation, the A.H. Zeppa Family Foundation, the Global Awareness Fund of the Duluth Superior Area Community Foundation, Whole Foods Co-op of Duluth, and Reader Weekly. Also received special support from the DeWitt and Caroline Van Ivre Foundation and from Mary C. Van Ivre in memory of the late William P. Van Ivre, former trustee of the college. I'm so grateful for all these sponsors. We couldn't do this without that kind of community support we're getting. Our speaker this evening is not a farmer, but she tells me that she hangs around with farmers a good deal, and she knows many farmers very well. What's more, she comes to us from Ames, Iowa, which, as we all know, I think is the heart of the American Farm Belt. Professor Kaleita earned a master's degree in civil engineering and a Ph.D. in agricultural engineering from the University of Illinois at Urbana-Champaign. She's currently an assistant professor of agricultural engineering at Iowa State University, where she teaches courses in soil and water conservation and engineering. She is particularly interested in the role of globalization in engineering and technology education, and in enhancing writing and verbal experiences for students in soil and water conservation. She received a Teaching Excellence Award in 2003 for her work in the classroom at the University of Illinois, Teaching Award 2 years ago at Iowa State. More recently, she's received the New Teacher Award from the United States Culture, and recently of all, the Young Educator of the Year Award from the American Society of Agricultural and Biological Engineers. She has published articles in both the academic and popular press, and is an Environmental Studies Fellow at the Pacific Research Institute in San Francisco. She is married to what she tells me is a great husband. His name is Greg, and he also works at Iowa State, and they are the mother of 1-year-old Lila. Please welcome Professor Dr. Amy Kaleita.
Thank you. Thank you, Dr. Morgan. I'm really pleased to be here with you tonight. And prior to coming over to the auditorium, we had a great dinner. I had some great conversation. And so I'm really excited to be a part of this seminar series. And I hope that I'm not just a very dramatic disappointment to those of you who are trying to put together a good series. So when I was asked if I would be willing to speak on the topic of the impacts of conventional agriculture on the environment, actually, when I was very first asked, I at first said no, because when I was asked, I said, well, usually there's a dinner and there's a talk and then there's a book signing, and I was like, oh, I think you might be going after somebody with a little higher status than myself, because I have no books. So I won't be signing anything afterwards. Although if you had like a napkin or something, I'd be happy to put my John Hancock on it. But when I finally decided, yes, this is something that I would like to be a part of, I thought, well, how would I begin to discuss the impacts of conventional agriculture environment? And part of my struggle in kind of wrapping my mind around what I might say to you tonight is that none of the terms in that phrase are things that have what is conventional? I found a photo from the UA that to me is conventional system. So there's strip cropping there, so that's conventional. All right, well, when I think of conventional agriculture, and the first I had was farming, however it is that your neighbors are farming, and not doing anything funny so that people are going to down the road is doing something very unusual on his farm. But perhaps a more realistic definition of conventional farming is that conventional farming is whatever system it is that the Farm Bill incentivizes. And incentivize is just a fancy word for makes that what everybody wants to do, because it's the most attractive from a profitability and ease of management standpoint. The Farm Bill, and I hope that that those of you attend the next talk in our series, because the Farm Bill is hugely influential on how our agricultural systems evolved to be the way that they are. And it has a lot of quirks and problems and impacts. And one of those impacts is it's created a system that has a few really obvious unsustainable elements. Some of those, where those elements are, might surprise you. Those of you who are very familiar with agricultural production systems probably won't be surprised by anything that I say tonight. And for those of you that are familiar with agricultural production systems, I think you'll find that most of what I am going to say glosses over a lot of details, and there's some hand waving. I'm kind of oversimplifying things, and I am, and I apologize. And for those of you that are not familiar with agricultural systems at all, you're probably going to feel like I'm throwing too many details at you and I'm making it seem more complicated than it probably is. And I might, though I apologize to all of you for whichever category you fall into. So. But I thought, okay, so this Farm Bill definition is probably accurate, but it doesn't really explain what conventional farming is. So I tried to find an alternative definition that captures most of the elements of conventional farming. And so I found one from the University of California at Davis that defines conventional agriculture this way: an industrialized agricultural system characterized by mechanization, monocultures, and the use of synthetic inputs, such as chemical fertilizers and pesticides, with an emphasis on maximizing productivity and profitability. And industrial agriculture has only become conventional within the last 60 years or so, since World War II. And that definition itself has a lot of elements to it. And if we try to break it into pieces, we look at what does the phrase industrialized agriculture really mean? And to me, and how it impacts conventional agriculture is really looking at applying some of the successful approaches for other types of industries in terms of minimizing the amount of time spent to produce the same amount of product. So to me, the industrialized agriculture has been all about maximizing the time efficiency of the way that our food is produced. Characterized by mechanization. As an agricultural engineer, I love me some mechanization, so I'm not going to say anything bad about it. But it has enabled a certain type of system to evolve, which has challenges, but also presents some wonderful opportunities. Somebody should ask me later about this really excellent asparagus harvester I once saw demonstrated, because it's fantastic. It's also characterized by monocultures, and what monocultures mean is growing just one crop as far as the eye can see. And living where I do in central Iowa, boy, you really get a very good sense of the extent to which the central portion of our country is in monoculture. And I'll talk a little bit more about that in a minute. Use of synthetic inputs like chemical fertilizers and pesticides, and I'm going to hit on that later in the talk, with an emphasis on maximum and profitability. And I think this part of the definition is maybe a little bit weird, because I don't think that before this conventional system evolved, nobody cared about profitability or productivity. Of course they cared. Farmers still had to make a living, and we still had food that needed to be produced. But I think that it's more that chemical machinery developments have promoted that time efficiency that has really risen to the top of what people are going after when they are doing a conventional system. So that sort of encapsulates what I think of as conventional agriculture. I'll talk a little bit more about it later. So then the next piece of the puzzle is, if we want to talk about the impacts of conventional agriculture on the environment, we have what we mean by the environment. And the environment is really an web of a number of systems. Water systems, so we need to think about water quality, we need to think about water quantity. We'll think about soil quality, we'll think about soil quantity. We'll think about air quality, and certainly agriculture has a number of impacts on air quality. Currently, climate is as in the current analysis of greenhouse gas pesticides, and so that sometimes gets lumped in here, even though it's not necessarily part of the natural really normally be concerned about. And certainly ecosystems, if we take a look at things like biodiversity and the health of our wildlife, and is our soil full of worms, or is it kind of barren of microbes and creatures? I couldn't possibly talk about environmental impacts in all of the areas. No, I could talk about them, but we'd be here all night. So the ones that were either squarely in my area of expertise, or were ones that I thought were maybe the most interesting, or just the ones that I wanted to talk about. So, and then when we talk about agricultural production systems, all agricultural systems, conventional, unconventional, there are a lot of moving in an agricultural production system, and I don't just mean that in a mechanized way. It's not rolls across the ground, although that's, got my little combine in the photo there. When you think about all of the things that go into planning and executing a successful agricultural production system, there are questions about how you're going to manage the soil. And coming into play there are some of those things on the row. Crop rotation. What is it going to grow? More than one thing? Are you going to grow one thing one year and then something else the next year? Are you going to grow two things in 1 year, and are you going to grow next to each other? Are you going to grow them on top of each other? Are you going to grow one after another? So deciding what crops and varieties to grow and in what sequence, and whether to double crop or to leave land fallow for a while, or plant a cover crop, all of those things are decisions that have to be made as part of an agricultural production system. And in a moment, I will get to what that decision turns out to be in a conventional sense. So another element of the agricultural production system is tillage operations. So deciding how best to prepare the soil for growing the things that you have decided to grow. And you want to do that in a way that not only makes a nice environment for the plants, but also preserves nutrients and soil moisture and fertility. And then you're probably going to think about conservation structures. Are you going to leave the landscape exactly as it is, or are you going to put some things in place that help you to manage soil and water resources? So maybe you've noticed that your particular farm has a tendency to have a little bit of soil erosion in an area of concentrated flow, and maybe you've decided that you're going to put in a grassed waterway, take some land out of production and create a grassy area so that that erosion doesn't continue to happen year after year. Or maybe you're going to put in a pond, or you're going to do some other sort of structural engineering work as part of your overall production system. And then certainly you're going to think about how are you going to manage pests. Pests are just a part of life. And that's true, you know, in your house, and it's true in your farm field. And the types of pests that are of significant concern in the agricultural production system are mostly going to be insects, because you don't want them to munch all of your crop to the ground. They're going to be weeds, because weeds are very good at competing for resources. And so they will steal resources away from the plants that you're trying to grow. So you're going to want to control the weeds in some way so that you don't have just a farm field full of weeds instead of a farm field full of crops. And then you're also going to want to have some way to manage the occasional disease outbreak that's inevitable, just a fungus or some other kind of infestation. So determining how to control and manage those pests is going to be something that you're going to have to think about. You're also going to have to think about how you're going to manage nutrients on your farm. So crops need nutrients in order to grow, and so you're going to have to provide them one way or another. You'll get some from the soil, but if you rely just on the soil, you will start depleting those nutrients from the soil, and you will eventually, long haul, run out. So you'll need to have some way to maintain the nutrient content that your crops will need. And that requires you to be able to figure out how much they need. And that can be a significant challenge as well. If there are any livestock involved in your system, they will excrete, and you will have to figure out what to do with it. So, and this is probably a little bit rude of me to say, there are people that make their entire careers out of studying manure management. And I'm glad that those people do that so that I don't have to. So determining the manner of collection and containment and then dispersal and all of that stuff poses a significant challenge. You're going to want to think about how you will make sure that your crop has, and you're going to want to think about what to do if your crop has too much. This issue of where does the water go if your crop is not using it, and what does it carry with it when it leaves, is a significant concern, and we'll touch on that a little bit later. And it relates to that last blob there of irrigation systems. If you decide that you need to routinely supplement with additional water, then you've got an entire irrigation system to manage, and what kind of system are you going to use, and where are you going to get the water, and all that stuff, and how are you going to make it water efficient and fuel efficient, and all of those things can be major questions. Farm management is becoming increasingly more intricate. This is really who decides what happens on your farm. And there's a huge diversity in farm management systems in this country. And like in the area where I live, it's not uncommon for the owners to be fairly far removed from the on-the-ground decision-making process. That the people that own the land are not necessarily the same people that farm the land. So how do you manage those competing interests? And then increasingly, with our ability to have sort of intricate information systems, the GPS technology and database systems, how are you going to manage all of your farming information? And it's not just bookkeeping, but it's also if you're having soil tests done, how do you create a map from your soil tests? Things that like maybe they should be simple, but are not actually simple when it comes to actually generating information just from data that you're getting. How do you do that, and what kind of systems are you going to have in place? And then the choices within all of those different management areas are not mutually exclusive. So even within what I'm calling conventional agriculture, you just start getting all of those interconnected pieces moving at the same time. And you can see that from farm to farm, even if to the naked eye it appears that it's exactly the same as the farm next door, it'd be very different in terms of how they were approaching all of these bubbles. But again, if I to talk about all of those things, we would all be exhausted. So I'm focusing on just a few. Lumping nutrient management and manure management together, because from the perspective of soil and water conservation, which my expertise is, nutrients, whether they come from synthetic fertilizers or whether they come from manures or nutrients. And the plant also doesn't really care. It cares a little bit. We'll get to that later. So I'm lumping those two together. I'm going to talk about crop rotations. I'll talk about tillage, management, and I'll warn you, that's the one that I know the least about in terms of my book learning. But it's so important that I thought I would be remiss if I didn't talk about it. And then kind of woven into many of those conversations will be issues of water management. So I'm not really talk about that specifically by itself, but you'll see it as a recurring theme in the number of things that I have to say. Okay, so let's take a look at the crop rotation. There are many, many in the world. But for the sake of discussion, I've decided to focus on just one type of cropping system. And because of its predominance in the American diet, and because of its emerging importance as a potential energy source, and it's the star of its own documentary, and controversial, it makes sense. And corn actually comprises just over a third of all of the cropped acres in the U.S. And so it's really the agriculture system. So as I mentioned, the Farm Bill earlier, federal policies influence farmers' choices of crops and management practices because farming is a business. And so when there are government incentives or programs, it's understandable that people would avail themselves of those resources. And for a variety of reasons that perhaps your next speaker will discuss, the Farm Bill really likes corn. So corn has really been among the chief beneficiaries of the Farm Bill. And as a result, if you travel through Iowa in July, you will see so much corn, so much corn. You won't even believe it, so much corn. When my dad came to visit Iowa, and my dad's not from a farming background, he was like, how could anybody possibly need this much corn? Well, and corn is it's in everything. I mean, your diet is probably, and my diet as well, is more corn than you could possibly imagine. But true monoculture, so growing just corn and only corn, is actually not that common. And there are several reasons why that's the case. And I'll talk about that in a minute. So it's somewhat challenging to grow just one crop year after year after year after year. So it has a very nice logical partner in another major beneficiary of the Farm Bill, and that's soybeans. So talk about agriculture. A lot of the country, what that boils down to is some sort of around producing years of corn and soybeans. So in most corn production systems, this is cropping patterns on corn for the 10 states that produce the most corn. What kind of crop rotation are they using? And you'll see, just as I said, the big blue bar in the center, most of it, year after year after year, is corn and soybeans. And there's a little bit that is corn after corn after corn after corn, but it's relatively small, and it's been decreasing, although some of the ethanol buzz has generated more interest in continuously cropping corn after corn after corn after corn, because now there's so many more things that you can do with corn. And then some other rotations in there as well, but the vast majority is going to be a corn-soybean rotation. And the reason that rotations are so popular, there's several reasons. The first is there are some soil fertility. So an individual type of crop will require certain things to grow, and it requires them in fairly regular proportions. So when you grow the same crop year after year after year after year, you are continuously demanding the same proportion after same proportion after same proportion of nutrients from your system. And this can be very difficult to manage unless you are applying lots and lots of additional inputs. When you start to build in some crop rotations, there's more of a diversity in demand, and so you don't have some of the same management struggles that come up when you're trying to grow the same thing year after year after year. One of the reasons that this rotation is so nice is that corn requires a lot of nitrogen. Well, actually, they both require a lot of nitrogen, but corn will get it all from the soil. And soybeans will actually take some of it out of the atmosphere, which is nice, because the atmosphere is 80% nitrogen. Or is it 70% nitrogen? Well, it's mostly nitrogen, right? It's mostly nitrogen gas. So soybeans can fix nitrogen by sucking it out of the air. They don't require taking it out of the soil. So this makes some of your nutrient management a little if you're doing a corn and soybean rotation. The other reason that rotations are popular is that most pests are crop specific. So like a soybean aphid, for example, really likes to eat soybeans and doesn't really care so much about corn. So if you develop a pest infestation one year, and then you're growing something totally different on that same plot of land, the next year, the infestation kind of goes away by it. Do a lot of maintenance to bluff whatever, okay? So pest management becomes a lot easier when you have rotations going as well. We'll see a little bit later that just a two-crop doesn't really maximize the benefits of doing rotations in terms of and decreasing your requirement for pest management. It's better than growing just one thing year after year after year. Okay, so we'll revisit the idea of crop rotations at various points in the rest of the discussion. Okay, so I mentioned plants need to eat. So this table shows you the major nutrients that most plants will like to eat. The primary nutrients, nitrogen, phosphorus, potassium. Secondary nutrients are required in kind of intermediate quantities, and then the micronutrients are required to low. So plants will be extracted, so the nitrogen fixation in soybeans and other legs of the air I mentioned earlier. So over the long term, on a global scale, the extraction of nutrients from the plants, use them, and they grow, and then the plants die, or somebody eats them, and that the dead plants decay, they return those nutrients to the soil. When someone or something eats the plant, that someone or something will excrete, and then the nutrients go back to the soil. So overall, there's no net loss of nutrients, right? The problem is that we can't really look at these systems on a global scale and over many millennia at a time, because problems will crop up on a much shorter time scale and a much smaller spatial scale than that. And furthermore, it sounds very sustainable in theory, but the way that our systems have evolved, and we have these vast expanses of corn alternating with soybeans, the scales are all off, right? So we're usually not able to return nutrients to the soil as rapidly as we are extracting them when we are growing crops in this way. So this is how fertilizers evolved, and fertilizer has been used for millennia, and probably the oldest type of fertilizer is animal manure or human waste even, because it's very nutrient rich. You return those nutrients to the soil, use it as a fertilizer. There are some problems with that I'll discuss in a minute. So I'm going to focus on nitrogen, and really the two biggest players in the nutrient issue. Potassium is usually available rapidly and in large quantities from the soil. When we talk about fertilization, nitrogen and phosphorus are really two of the most important ones, right? Okay, so we talk about how to supply the nutrients that a crop needs. Well, we could use animal manure. Animal manure does contain most of the nutrients that a crop would require, but it doesn't necessarily have portions that the crop needs. So if, for example, you have a crop that demands a lot of nitrogen and just a little bit of phosphorus, but your manure content is the other way around, or not exactly in those proportions, you have an excess of something. And you'll have to either supply just enough to meet what it is that is not excess, and then apply the other one from somewhere else. Or you'll have to recognize that you're going to have waste in the system. Well, and who cares if there's waste in the system? Wouldn't we just have a buildup of nutrients in the soil, and wouldn't that be just, even more fertile? Well, but no. And the problem is that those extra nutrients are going to go somewhere. In the case of nitrogen, most forms of nitrogen in the soil are really water soluble. So you get a good rain event, and those things are going to trickle right out of the bottom of the root zone. Where I live, most of our farm fields have subsurface drainage systems installed underneath them to improve the infiltration capacity of the soil. And so that creates kind of a superhighway for that nitrogen-rich water to exit and out into our surface water supplies. In the case of phosphorus, phosphorus binds very tightly to sediment particles. And so anytime we have a runoff event that starts to move those particles, take some of the phosphorus with it, and then if it moves far enough, will also end up in one of our surface water supplies. The problem with excess nutrients in a surface water supply is that they operate the same way that they do in the farm field when they're in the water. They're a growth promoter, and they promote the growth of aquatic vegetation and algae. But you don't necessarily want that stuff in your water supply, and you certainly don't want it. You don't want algae blooms in your drinking water, and you don't want it in water that you're going to be using for a number of other purposes either. One of the problems, it's not just aesthetically displeasing, although it is. It can be kind of stinky. When those algal blooms inevitably start to die off, the decay process consumes a lot of oxygen. And there's like some chemical reactions inside. I only took one semester of chemistry. But basically, that decomposition process will use up oxygen from the water. And now you've got a system where all of that nutrient-rich water has created low dissolved oxygen content. And anybody in here is a fisherman, you know that fish like very bubbly, well-aerated water. And so a low dissolved oxygen content in the water is a very hostile environment for many aquatic fish, and unhealthy ecosystem nutrients in your water supply. So when you have a fertilizer that is mismatched crop demand, there are negative environmental consequences of using manure. So when we talk about conventional agriculture versus, let's say, organic agriculture, and some people think, well, fertilizers is totally bad for it. You have to consider of commercial fertilizers you to mix up fertilizers in exact right proportion. Well, in that, even if you get the proportion, you don't necessarily get the timing, and you have to consider that really you need to apply the nutrients exactly, because if you get a big rainfall event, you've already applied the nutrients, the crop hasn't used it yet, they're flushing out of the system. So even with commercial fertilizers, even though there is that significant advantage that you can get the proportions correct, still managing those fertilizer applications with a minimal impact on the environment is a challenge, because there is one enormous variable in the farm production system that even with the best and most intense management, you could never control, and that is the weather. And the weather will bungle up a lot of the things that you try to do. Okay, so, and in my discussion, I'm sort of using the conventional agriculture versus organic agriculture in contrast as a rhetorical device. In truth, neither one of these systems are completely well-defined, separate from one another. They're all a combination of different practices. And in the case of certified organic, it really just means, did you do this practice and this practice and this practice? So that particular set is well defined. But beyond that, there are going to be a whole enormous host of things that, that you are doing or are not doing that your conventional counterparts might be also doing or not doing. Okay? So, but one of the major differences between conventional and organic farming is where does the fertilizer come from? The plant doesn't really care. It cares a little bit in the sense that one of the other struggles with manure fertilizers is that the forms in which some of those nutrients are available are very slow to release. So they're not necessarily available to the plants right away. And in chemical fertilization, they are available as soon as you put them out there, or if you have a slower release one, if you're trying to manage that way. So the bottom line with the nutrient management question is that the environmental impacts on soil and water when it comes to pollution. That's a term that's maybe a little bit, nutrients are not really a pollutant, but they can be if they are in the wrong place in the wrong concentrations. Neither one of these systems is perfect. So using manure fertilizer is fantastic. You've got a naturally occurring fertilizer source, but there are problems associated with that. Managing chemical fertilizers can also be very challenging. So I think where use of manure fertilizers has, if you pardon the bad pun, a leg up on using commercial fertilizers is that commercial fertilizer production is a little fertilization. Nitrogen fertilizers actually use natural gas as a feedstock, so it consumes natural gas just because that's where the nitrogen is coming from. That's also the whole production system and how do you create it and transport it and all that stuff. Fossil fuel. And to talk about agricultural impacts on climate change, commercial fertilizer application is one place where there is tremendous room for improvement. Okay, here's another example of why this fertilizer issue can be such a challenge. This is a map of manure capacity in terms of nitrogen and fertilizer. In terms of nitrogen or phosphorus growing, you can see that there are places where we don't end up with excess, but there are places where we really do end up with excess. And you'll notice that the maps are not completely identical, so it doesn't necessarily just mean that one area is producing too much manure. It's because of this imbalance in the nitrogen and phosphorus content in manure. So just a sort of little example of where some of the challenges are physically located in terms of creation of animal manures. Right, so, and that is why commercial fertilizers have become so popular. So this is a graph of fertilizer sales in tons per year, from the 1940s onward. You'll see that, phosphorus, a little uptick, and then it's kind of leveled out, and nitrogen, quite a significant amount, okay? And example of regions in which this fertilizer situation from wherever you're getting it can cause problems. This is, so I'm from Iowa, so this is readily available to me. The estimated nitrate Mississippi River from the state of Iowa. And you'll notice it doesn't really look like that graph, right? And it's because the main driver of nitrogen export to the Mississippi River is not fertilizer, commercial versus manure versus whatever, it's weather. So 1988 was a drought year, so really not very much export going on that year. 1993 was a very wet year, and it was tons of export going on, okay? And that, how the weather is going to turn out is not something that is known to the farmer at the time that he makes fertilizer decisions. So it would be very difficult to just wave your hands and say, well, we're going to use this type of nutrient management system, and suddenly all of our water quality problems are going to disappear. And if you take a look at where the places are in the country that are causing problems in the Gulf of Mexico because of this nutrient export to the Gulf of Mexico, out through the Mississippi River Basin, creating this very large hypoxic area, this low dissolved oxygen content in the Gulf of Mexico, and creating problems for the fishing industry there that relies on good dissolved oxygen. You see this kind of ugly little hot spot right in Iowa, Illinois, Indiana in terms of nitrogen. And interestingly, the phosphorus graph is not quite the same. Suddenly, Missouri seems to be a big problem. It's actually because of the amount of animal production going on in Missouri. Is a grazing agriculture situation. So most of the animal agriculture in the state of Iowa is going to be in a confined operation. And we could argue about the relative values of confined animal operations, but one of the things that that does do is it makes at least the collection part and the testing part of your manure a little bit easier because it's all in the same spot. When you move to a grazing kind of operation, then your manure is a little bit all over the place, and it can be much harder to manage. And how do you make sure that, well, are we applying this over the right amount of land, and when the animals are just wandering around kind of doing as they please, right? So if you were waiting for the part of the presentation where I said that one of the solutions for animal manure management is going to be to move from confined operations to grazing operations, then you'll have to track me down at the end of the talk, because I'm not going to say it here because it has associated with that as well. The manure is simply more difficult to manage on those grazing lands. Okay. So moving on. When you are growing crops, as I said, you're going to have pests. So something else that you need to do when you're raising crops is to make sure that they're not crowded out by weeds or consumed by insects or fungus. And there's an interesting history of pesticide use and public perception of pesticides, but I'm not going to go into that. But what I do want to do is differentiate between common pest control strategies in conventional and organic systems, because I think this is where most of the public feels like the big benefit of organic agriculture is that organic agriculture does not use pesticides, and conventional agriculture uses lots of pesticides, and it's bad for the environment. Okay, so organic systems use no pesticides, and conventional systems almost always use pesticides. That part is true. Although, since the early 80s, you'll see that there's been kind of like a little bit of a decline in pesticide use for a variety of reasons, including that some land has come out of production under certain farm programs, that new pesticides are developed that are just as effective at lower rates, so we don't need to use as much. And also the rediscovery of the concept of integrated pest management, so using a variety of strategies, chemical and non-chemical, to combat your pest rather than just using pesticides alone. And whether or not today's pesticide use is truly environmentally damaging is largely a matter of personal ethic. So, for example, I value biodiversity, and I like to have a healthy ecosystem. I have no problems calling out the exterminator once a year to eradicate the carpenter ants that live in my neighborhood. But I don't want them munching on my house. They are not, to me, a valuable part of the ecosystem in my very local environment. Okay? Doesn't necessarily mean that I want my one-year-old daughter licking up the pesticide after the guy has sprayed, but I'm willing to take on the risk because I can see the associated benefit. So likewise, I personally don't have a problem with judicious use of pesticides, and I appreciate the modern approach to chemical licensure and pesticide application that tends to be fairly conservative. But I recognize that there are very well-informed people who have a completely different viewpoint than I do, and I think that's fine. So I could go on a little bit more at length about pesticides, but I truly think because it is a matter of personal opinion, to me, I cannot necessarily document any quantifiable negative environmental impacts from current pesticide use. Maybe that's very controversial. Somebody can feel free to call me out on that later. But there's another aspect to the pesticide discussion that I think deserves a little bit of play, and you can see that. You can see right here. This, the biggest component of the total pesticide use is weed killer. And there was a big jump in use of herbicides from like 1960 to say the early 80s. And in fact, as a percentage of applied, in 1966 it was about a third of those herbicides, so a small percentage. In the modern section, it's almost 80% or more of the applied pesticides is weed killer. Part of the reason is that during this time there was lots of aggressive research into the development of new pesticide, but another reason that herbicide use has kind of dominated the pesticide market is the introduction of conservation practices. This is where we kind of bridge the gap from one of those bubbles. One of the things we'll do, and let's talk about tillage a little bit. When you are farming, you're going to want to do something to prepare the soil environment for planting and growing your crops. So in many systems, you'll up the soil. So you kind of turn it over, you'll reincorporate some of those nutrients or decaying products that might be on the surface, and you'll bury them underneath. Tillage strategy is what we use in our garden at home, constantly cleaning up the soil. outside of where the plants are to get rid of some of the weeds. There are a number of problems associated with aggressive tillage that I will get into in a minute. But to combat some of those problems, there's been a movement underfoot to minimize the amount of tillage that is being done. If you are not using tillage, you will need to be a little bit more aggressive in your other control mechanisms for weeds, and that's one of the reasons that we've seen an uptick in the amount of herbicide use. So this is kind of one of those examples where the conventional system has produced something that's got a little bit of a yin and yang to it. The conservation tillage, which is becoming increasingly popular these days, it's almost percent of all farm fields are in some kind of conservation tillage, but it does require a little bit more weed control from a chemical standpoint. All right, so as I said, as part of a management system, tillage has several purposes. So one is to incorporate plant residues into the soil. You want to prepare the seed bed by loosening up the soil, aerating a little bit. But it also has negative consequences in that it will leave the soil vulnerable to erosion. So you can imagine that a soil that has kind of a protective cover of crop residues on the surface, you get a rainfall event, that protective residue will sort of buffer the impacts of the rainfall event. And you have less soil erosion, you also end up having less runoff because there are some things that you don't end up like kind of squishing up the surface of the soil, the impact of the raindrops, and you get this kind of thin seal on the surface, and then every additional drop of rain becomes runoff after that. So by not doing tillage, you are preserving or protecting the soil against high rates of erosion. Tillage also has a number of other problems, not just the soil erosion, it also damages the soil structure. So you're continually mixing it up, and you end up with kind of poor and unhealthy soil structure. Maybe that's a little counterintuitive. You'll also tend to increase runoff. You'll increase loss of water from the system by that breakdown of soil structure. And it's also a little bit of a vicious cycle, because every time you run a piece of equipment over the surface to do tillage, you kind of squish the soil a little bit more. You can cause the soil to become compacted, which exacerbates the problems of runoff, because now you've got this kind of squished up layer and the water can't get through, so it's going to try to exit some other way, right? So there are a number of negative consequences of tillage. And because of all those problems, conservation tillage, so doing as little tillage as possible, and in some cases no tillage at all, is a special kind of conservation tillage, no-till, has become very popular. So in some parts of the country, I'm moving on too fast. In some parts of the country, no-till is almost the standard. It's that popular. In the upper Midwest, like where I live and work, conservation tillage in terms of no-till is not quite as popular because there are several reasons. The biggest reason is that most farmers are going to want to get into the field and plant as early as possible. And tilling the soil allows them to do that because it will let the soil warm up a little bit faster, it'll dry out a little bit faster. So in some systems, there's a negative consequence of conservation and tillage, but in many systems, there's not. And so it's becoming very, very popular. And it's largely resulted in a decrease in net soil erosion rates across the country over the last 20 years or so. But if you are going for a fully organic system where you're not using any chemical weed control, you will find moving to a conservation tillage strategy very challenging, because you don't have the option of using chemical herbicides to knock out the weeds. You have to do some tillage. Now, I'm not saying that organic farming and conservative tillage are totally incompatible, but it does make for a very, very complicated management system. And so for that reason, the vast majority of organic farms use very aggressive tillage. So for example, in North, not unusual for certified to do 4 to even as many as 8 passes through the field of tillage per year, which is a fairly extreme amount of tillage in terms of its potential to damage soil structure, increase runoff, increase soil erosion. Okay? So there's a little bit of a, is organic farming really better for the soil? Well, in many ways it is, but that's one area where I think there is significant room for improvement in terms of organic farming, is this issue of how much tillage an organic farm tends to do and the increased risk of losses from the system in terms of nutrients and soil. Another aspect of tillage that is complicating things is that mixing up of the soil will oxidize the carbon in the soil, and that is one of the sources of greenhouse gas emissions from agricultural production, is tillage operations oxidizing the carbon in the soil. Oxidized carbon is CO2, and off it goes into the atmosphere and contributes to climate change. So once again, certainly much room for improvement to be made there. And interestingly, as if that was all not complicated and confusing enough, there's also the issue of genetically engineered crops that really comes into play on this particular aspect of the environmental impacts question. In the United States, USDA surveys indicate that most farmers have adopted genetically engineered corn, cotton, or soybeans because they wanted to increase yields through improved pest control. So in the US, most of the genetically engineered crops are used mostly for pest control purposes. So, and there are a couple of different mechanisms by which that happens. One way is the sort of HT abbreviation on this graph indicates herbicide tolerance. So these are crops that you can spray with a particular type of herbicide and they won't die, but everything else will. So they're very popular because that allows you to just use one herbicide and you just do it once and you kill all the stuff and your crop is still fine. The other type of popular genetically engineered crop in the United States is this BT cotton and BT corn. Bacillus thuringiensis is a naturally occurring soil bacterium that produces a toxin for certain types of pests that are common in cotton and corn. And if you have a lot of that in your soil, you will have a natural defense against that particular type of pest. So what the genetic engineers have done is inserted that bacterium gene into the cotton and the corn so that the cotton and corn themselves will express that toxin. It's very specific to that certain family of pests. And then you don't have to apply anything to control that sort of pest because the corn and the cotton will do it for you. Of course, genetically engineered crops are very controversial, but they have resulted in net decreases in herbicide use across the country. So there is that advantage. Interestingly, particularly on the BT side, the soil bacterium itself is an approved herbicide, or pesticide rather, for organic farming, right? So you couldn't use the genetically engineered crop that expresses the toxin, but you could just put the bacteria right in the soil and have the soil bacteria express the toxin itself. This is another one of those cases where I feel like maybe the arguments for what's more environmentally damaging or isn't or is not gets a little bit abstract because where the toxin comes from the soil by the plant. And does the rest of the ecosystem care whether it comes from soil or it comes from the plant? Maybe not. So, when you look at herbicide-tolerant varieties, okay, soybeans, are especially known to herbicide-tolerant variety because of this relationship between tillage and herbicide use, is that genetically engineered soybeans that are designed to be herbicide-tolerant, more and more acres to be put into systems with conservative tillage, okay? So, like I said, this is one of those areas where the genetic engineering has been perhaps some protection to our soil resources. Okay, to sum up. And again, I'm using the conventional versus organic as a little bit of a rhetorical device here. When we talk about the likelihood of nutrient losses from these systems, both conventional and organic farming are risky. They have inherent risks in them that you will, the right weather circumstances, lots of nutrients, and when you lose them, they will almost cause quality problems downstream where. Look at greenhouse gas emissions. The major source of greenhouse gas emissions in a conventional system is going to be from synthetic nitrogen fertilizer production. We're going to get a lot from tillage. In organic farming situations, you will have a lot of greenhouse gas emissions, and sometimes a lot of because of the amount of tillage commonly used in those systems. As a result, when you look at soil loss, both are risky. Conventional and organic farming can both result in high rates of soil loss if they are improperly managed. In conventional, it is more likely that you can use basin tillage as a method for mitigating against soil erosion, and less likely that you can do that if you're using an organic system. When you look at biodiversity, so the danger that is posed to all of the different types of organisms that live in these ecosystems that we're talking about. In a conventional system, the biodiversity is at risk because you are using synthetic pesticides to selectively reduce the biodiversity. But you're also selectively reducing biodiversity in an organic system. You're just going to be using different types of it for doing that. So to me, if I were to try to determine from all of these the environment that I care about, which system is more beneficial, I have a hard time saying one is definitely better than the other. So if I were to try to summarize what are the major benefits of each one of these systems, to me, the conventional systems have a major benefit in that they are very efficient. So you can produce a lot of stuff. It kind of does take a lot of resources, but you can produce a lot of stuff with a fairly small investment of time. In an organic system, you often have to invest a considerable amount of time to create the same amount of stuff, or maybe even a little bit less stuff. However, if properly managed, the soil benefits can be very significant in organic systems, and to me that's where the major impact is. But a lot of that, how significant is it and how beneficial is it, is going to depend on variables that are beyond our control, and that are beyond your control by the organic product. So I care deeply about the environment, and I like to eat. So when I make these decisions about organic versus conventional, I usually just go by taste. There are some things that I don't waste my money on in terms of organic versus conventional. They don't taste any different. I'm not particularly concerned about pesticide use from my research that the pesticide residue on conventionally farmed produce is usually very, very low. And it's well below any EPA and FDA standards for pesticide ingestion. Even though nobody wants to ingest any pesticides, you do it just by existing. So I'm willing to risk food. But a lot of times, I will make a decision to buy organic because it just tastes better to me. So they're often smaller, and sometimes because they're not using preservatives, they come from a closer distance, haven't had to be picked so early or whatever, so there are times I will buy organic just because I prefer it. But I don't kid myself by thinking that when I buy my organic bananas, I am contributing to saving the world and preserving environmental quality. If I don't think that organic farming is de facto the answer to all of the environmental problems that are related to production agriculture, where are the areas where I think that we can see the most benefit? Diversified farming systems. I think the corn, soybean rotation, great, it's a rotation. There's some benefits to be had there. But that's like saying you have a balanced diet because you eat at Wendy's and at Burger King. So I think that moving towards diversified farming systems that include many more things in them than just corn and soybeans is going to result in significant environmental benefits, particularly on the nutrient. The most obvious ways can support diversified farming systems and local food. The reason for that is if we start to demand that the diversity of our diet comes from local sources, we will create locally diverse systems. If we say I want to have a diverse diet, but I'm willing to get all of my this from this area and all of my that from the other area, it really helps support this movement farming small scale. I also think that we need to be much better at multifunctional landscapes and services here to talk about and provide besides just food. Water quality, some constructed wetlands into our landscapes. If we have buffers at the creek, we create nice and healthy ecosystems through things on the landscape besides just a crop. I also manage tillage, and I don't think you're doing conventional, organic, whatever. Tillage is a big deal, and it will only become deal as it becomes more and more of a. Along those lines, I think anything we can do to energy efficiency that we are better in the that's kind of an overarching most aspect like that thing to do to improve energy will almost always shrink your environmental. So those are where I will spend the most of my time in terms of minimizing the impact that on the environment. This is part of the presentation where I become a shameless self-promoter. So if you are a student, or if you're not currently a student, but you think you might like to be in graduate school, and you're interested in all of the issues that I brought up tonight, I would encourage you to investigate my institution. Not only do we have programs in agricultural engineering and agricultural systems technology and management, but we also have interdisciplinary programs in environmental and sustainable agriculture, and I'm on both of those. For the right students, there is always an opportunity and fun. So if you get a little bit of science and a little bit of math and a lot of passion, then you will want to come first to investigate some of those opportunities. If you are an undergraduate and you say that sounds cool, but I'm not, summer internship programs as well, and you're welcome to talk to me about any of those too. So with that, I will open it up to questions.
Thank you for your interesting talk on the future of agricultural systems. One thing that we frequently hear about in reference to global warming is increases in dramatic weather pattern changes where we go drought and flood, drought and flood, and large parts of America or the United States and in particular Africa becoming significantly more arid. What do you envision? Is there a particular crop that Iowa can be growing when there's 70% less water there, or do you have planning that you're going to already develop for such circumstances?
Yeah, so it's an excellent